In lesson 2.4, we're going to play around with proportional relationships, which means we're playing with ratios, and ratios are just division. So we have two different numbers we want to compare, and we can divide them, and that will tell us, say, how many times bigger or how many times smaller one is than the other. We can also use that to talk about things like rates, miles per hour, or in this case, we're going to look at people per square mile or people per square feet, which is how we measure population density. So for example, there are the population has grown a lot on the Earth, and we're approaching 8 billion people now, which is a lot of people on the planet. So we're going to start off by imagining a stage that's 20 feet by 20 feet. And in there's 100 people. So there's 10 people across and there's 10 rows. And so if we have 10 people across, then that 20 feet must be split up into groups of 2. So each square someone is standing in is 2 feet by 2 feet. So that information is stated up here, and this is the illustration of it there. To calculate the population density, we just take the number of people and divide by their area. So let's make a note of that for population density. So it's always number of people divided by the area that they are in. And number of people is pretty straightforward. Area could be measured in a few different ways. So sometimes we'll measure area in square miles, which we might abbreviate as SQMI. And sometimes we might write it using a power. So miles MI squared. And other times, like in the examples we're playing with here, we might use square feet for smaller populations, for smaller areas, which we might abbreviate as SQFT, or feet FT squared, square feet, feet squared. And there's a few different ways we can view this situation. So it's 20 by 20, 20 times 20, 20 is 400. So one view of the population density in this case is 100 people divided by 400 square feet. And that can be viewed in different ways depending on how we clean up that fraction. So in that illustration, we had 100 people occupying 400 square feet. So that 100 over 400, we could also say that is people per, right? Per means divide, square foot. That could be reduced, so we could say it's 1/4 people per square feet, or 1 person per 4 square feet. There's a bunch of ways to think about that. And 1/4 could be written as a decimal. If you plug it into your calculator, you'll see that's 0.25 or 25 hundredths. And again, people per square foot or foot squared. So there's a few different ways to view a population number like that. The original numbers in division, or we could clean that up and write it as a unit rate, which is what this last one is, where the denominator is 1. So now we're just going to imagine that there's a nearby patio that's 10 feet by 10 feet, and there's 25 people there. How does this population density compare with that of the stage? Is a a 10-foot by 10-foot area with 25 people in it more or less dense in terms of how much elbow room the people have than this situation here. So I'm gonna let you think about that one and pick an answer here. And it might help to draw it out. And let's think about that here too, slightly different scenario. We have the same 20-foot by 20-foot stage, same 100 people, but the people move around. So there's going to be groups here and there. So there'll be some more tightly packed people up here maybe and over there, and then other people are just kind of wandering around loosely over here, but it's the same number of people in the same area. How would that second situation compare in population density? Is it the same? Is it smaller? Is it larger? So I'm just going to draw a quick picture of this and let you answer the other. So we have a 10-foot by 10-foot region. So let's say this is my 10-foot by 10-foot region. And I have 25 people in there. So 10 feet by 10 feet, 25 people. And 25, think about that for a minute, that's 5 by 5. So kind of similar to the picture I have over there, my people could be arranged like this. Best art project today in a sort of grid. So each person, again, 5 people covering 10 feet that way, 5 people covering 10 feet that way. Oh, look, they would live in their own 2-foot by 2-foot square. So something to think about in answering that first question. Let's take a look at the next. So this here, actually, let's go up here. Slightly different situation. So now we're imagining a classroom full of students, and the classroom is 20 feet by 18 feet, and there's 30 students occupying that. So we want to calculate the population density for this. So let's do that. I'm going to take a quick screenshot of this. Oops, I just broke my, ooh, it's not what I wanted to do. Let's try that again. There we go. All right, so let's play with this situation here. So we want to consider the population density of this situation. And remember, population density is always people divided by area. So the people here, well, that's 30. And the area here is the 20 feet times 18 feet. Let's just check that out on a calculator. D times 18 is 360 square feet. So we have 30 divided by 360, and that's people per foot squared. And we could clean this up a little. So right away I can see I could divide top and bottom by 10. So I could say, well, that's 3 over 36. So another way to look at that is that's similar to having 3 people for every 36 square feet. And then I recognize, well, 3 goes into 36. So I could say that's 1 person for every 12 square feet. 3 goes into 36 12 times. And thinking about as a unit, we could check out 1/12 on a calculator and get a decimal version. We'll double check that I got that right, 0.08333. So let's round that to 2 decimal places, should be good enough. So that is about approximately 0.08 of a person per square feet, which is kind of weird. All right, so let's see, double check what we were asked to do here. So I was just playing around with the numbers. I've got my 30 people in there, 18 foot by 20 foot. 18 times 20 is 360. We want to calculate the population density rounded to two places. So there I have rounded to two places, and we need to choose the appropriate units in the little box on the problem. So I think we've got that nailed down there. And let's just double check that I didn't mess this up in my 1, 2, 3, 4 steps there by just taking this original and plugging that into my calculator. So thinking about people per area, we have 30 people divided by gives me a fraction on this calculator, and the area is 18 times 20. And see, I got the same number I got there. So you should play around with your calculator, trying to verify the things that you did. All right, so next we're going to mix things up a little bit, and we're going to take our people in their classroom, and we're going to form a city in one corner of the room, and we're going to have a suburb in the other corner of the room, and each have their marked off areas that they get to live in. And then we have the rural people outside. So we have the same 30 people, but they're distributed a little bit different. So there's a city population density here, and there's a suburb population density here. And then the whole square is going to be the county population. So you have a few questions to answer about that. And we're going to play around with looking at square miles instead of square feet. So let's play with this one. I need all of this. All right, let's see, what do we got here? So again, we have a city, we have a county, and we have a suburb. So I'm just gonna list them each out here. So city. So in the city down here, it says the city has 16 students. 2, 4, 6, 8, 10, 12, 14, 16. Yep, that looks good. So we have 16 pupils per, and that one is 8 by 8. So 8 times 8 is 64 on a good day. We'll double check that on a calculator. So 64 square feet. So then this calculation right here should be the people per square foot, the density for square feet area for the city. And then we have our suburban. And there we have 12, 2, 4, 6, 8, 10, 12. Yep, looks good. 12 is given down here too. And they have a little bit more room to play. So they're in a 10 by 12 or 120 square foot area, right? Feet times feet is square feet. So then this calculation would be how we could get their unit rate for the population density. And we can also check out the whole county. And in the county, we still have the same 30 students we had before. And we still have the same area we have before, that 20 times 18, which we've already calculated. So those are the calculations you need for the next few questions about this. And there's one particular question I want to make a note of. All right, compare the population density of the city to the suburb. The city is blank times more, the city, let's read that correctly. The population of the city is blank times the population density of the suburb. So we've looked at relationships like that before when in some other projects that we did. I just want to copy that sentence to figure out how to translate that into math. Oops. That over, clean it up a little bit. Population density of the city is blank times that of the suburb. Ooh, just happened there. I think I just crashed my system somehow. Darn. Let's see if we can recover. It's usually good about saving my work. Ooh, this one. Perfect. Okay, so we want to compare the city to the suburb. And so that relationship is pretty much as you see it. So we want to take the calculation for the city and divide it by the suburb. So let's make those calculations and then do this so we can talk about that comparison. So we have 16 out of 64 and 12 out of 120. So I am going to just move some things around here, make sure I get them right. There we go. Okay, so city, we have 16 people split up into an area that is 8 by 8. So that's 0.25, 25 hundredths, 1/4. And then for the suburb, we had 12 students in a region that is 10 by 12. And so that is 0.1. So we want to take those two numbers, the 0.25, 25 hundredths, and the 0.1, 1/10 in our comparison. So up here, city is 0.25, 25 hundredths pupil per square foot. And the suburb is 1/10 people per square foot. And so in our comparison here, we want to divide those two numbers. And just kind of looking at them, I'm guessing it's at least 2 times bigger, right? The city's 2 times more dense than the suburb. Let's just check that on the calculator by performing that division. So 25 hundredths divided by 1/10, and we get 2.5. So here I can see the population density of the city is 2.5 times the population density of the suburb. Does that seem reasonable, right? These people are pretty crammed in there, right? So it's more dense. How much more dense? 2.5 times the density of the suburb. All right, hope this was helpful. Come back with some more about this lesson shortly.